Hey, welcome back. Today I'm going to be showing you some of the exciting stuff we've been doing with the GenFEA Web Modeler interface. So what you see on the screen there is the new GenFEA Web Modeler tool, and it's currently a pre and a post processor for the GenFEA desktop app. But we are planning on building in a solver directly into the web interface as well. So first, I'll just show you how we load a bunch of materials and sections from the global library into the local project, and then I'll proceed to model a couple of elements and show you how that works, and then we'll move on to looking at how we can use the wizard generators to generate stuff automatically. Now, the web modeler is an improvement on the desktop app modeling interface. It is more parametric and smart, working with multiple levels and work planes that you can set active concurrently or separately depending on what it is that you want to do, and some really cool parametric tools to keep things connected and smart, as you would expect in any modern kind of 3D modeling sort of interface. Now, you'll notice at the bottom there we've got the input workbook. If you're familiar with GenFEA, then that will look familiar. So it's still building that database of information as we proceed through modeling the elements. And then, of course, as you saw there, we can copy stuff and move them across and array them quite easily. There's different kind of views that you can activate, and then, of course, different work planes that you can set active depending on what it is that you're doing and what it is that you want to be modeling, just to help make it a lot more intuitive and easy to generate models from scratch. Now, we've also built in some wizards. There's more to come, but at the moment we've got the portal wizard and the concrete building frame wizard. The portal wizard, as you can imagine, is a portal frame generator. I'll just load in a couple of sections here so we can map them against the parametric properties as you see there in the wizard dialog. And it's pretty comprehensive. It can do quite a lot. So it works the same way as blocks in AutoCAD would, so parametric blocks. Meaning that it is a container element with all the sub-elements driven by parametric connectivity. So right now I'm just assigning those sections that I brought in. I'm setting some parameters, and you can see we've ended up there with a decent looking portal frame with a double span. Now, at any point we can access the parametric block from various locations within the UI, and then we can go and adjust some properties again. Right now I'm just moving the bracing across to the second bay from the ends on both sides. And then we can also adjust the configuration for bracing, so there's a couple of options. We'll build in some more features, but as it is right now, it's pretty comprehensive, as you can see, and it does a lot of the solving of the geometry as part of the wizard, so built into that, keeping it smart. Now, at some times you might want to create your own custom elements. GenFEA would generate levels automatically based on the location of elements as you model it or use the wizards. So let's say we wanted to create a column element using those profiles we brought in earlier, and we want to place it there in the center to connect to the apex. Now, if we did that, and I'll just rotate this column to the correct orientation. If we did that, it's obviously sitting outside of that block. But notice what happens when we adjust the apex height there. You'll see that that column is, although it's been added afterwards as an add-on to that structure, it's still connected to it in a smart way. So, it keeps that parametric connectivity, and at any point if we want to explode that parametric wizard block, we can do that. And of course, all of the backend stuff and the input workbook is generated automatically and is bidirectionally linked. So if you change stuff here in the input workbook, it's going to update the model, and if you update the model, it's going to change the input workbook. The elements are also linked, so you'll notice if I select anything in the model, if I click on that rafter, it's going to select the associated row or input entry in the input workbook for that element that is being selected. And then, of course, there's the different configurations for various load case types and combinations that you can set up. I won't go into too much detail now, but it follows the same principles as the desktop app. And as I mentioned, there's a concrete building frame modeler as well. It's very basic at this stage. We'll make it a bit more advanced in the near future, but it kind of demonstrates a similar type of behavior. There's a bunch of stuff you can do working with shell and framing elements in a combined model, and it keeps things parametric and easy to work with. Now, another thing we can do here is we can bring in the traditional and native Excel workbooks that GenFEA Desktop uses. So GenFEA uses XLSX as the native file format. There's no proprietary file formats, right? Keeping it open and easy to work with. Now, this model was developed in GenFEA Desktop. It's one of the sample models, and here you can see it. That's GenFEA Desktop. And we just opened that same model in the web browser. But we've also exported the results. So you can export the results as spreadsheet format as well from GenFEA. And then, of course, within the viewer in GenFEA, we can display certain outputs for results. We can isolate it for different design groups, and then we can also plot those values in the plot view. Right now I'm looking at a single purlin, but we can use that select chain method to select all the connected elements in a discretized line. Now we can do the same in the web viewer. So if we load up the results from GenFEA, you'll see it'll overlay that onto the actual geometrical model, and we've got these different states in the web modeler. So there's the modeling state and the result state, similar to the GenFEA desktop app. And that, of course, helps us to display the results here. And what I'm doing now is we're looking at deflection, and I've just changed the maximum exaggeration scale there so we can actually see that deflected shape in real time as we use the slider to magnify that. And then, of course, we can do things like switch on and off text values of results within the model. So basically everything you can do in GenFEA Desktop, you can also do in the GenFEA Web, plus a little bit more. So you'll see for the different design groups, we can also isolate values and just see what we want to see at any given stage. And then, of course, if we switch to the purlins here and we use the selector, it will then allow us to view that plot view. And there's the select chain button, which means we can now also select the connected elements that is belonging to that same discretized master element. And then if we want to drill further deeper into the various segments, we can also do that. Now there's a bunch of other outputs that you'll see on the screen there. So we've got forces and moments, both for framing elements as well as the shell elements in the model. There's a bit more work to be done here. We're working on it quite actively. And there's more to come very soon. So some of the GenFEA features we're going to build in next is the solver. So pretty soon you should be able to run the solver as a hybrid tool. There will be a desktop service that connects to the web browser, allowing you to run analysis on models without having to have GenFEA Desktop installed, just the engine. And then, of course, the design components. So DesignMate and the AI features that we have in the GenFEA desktop app hasn't been brought across into GenFEA Web yet, but it will soon. This allows for a much smarter, more intuitive and responsive workflow and UI. So there's a lot more to come in this space. The time is right, the technology is right, and the browser capabilities are now enabling us to develop really smart tools such as this. So this is quite exciting. You can already access it. I'll paste the link in the description below. So feel free to have a look, play around with it, and keep watching the channel for more info. Thanks. Talk soon. Bye.